This conference will now be recorded.
Hi everyone, welcome to the AWS training program. So today we will be talking about very hot topic in the market nowadays, that is CICD, and we'll talk also about Git. So let's start the class with the agenda. The agenda for today's class is overview of CICD, which stands for continuous integration, continuous deployment. Then we'll talk about what is exactly CI concepts and what exactly are CD concepts. Then what are CI/CD tools? So first of all, CI/CD is not an AWS service. It is a concept. So this is just a concept, and in order to achieve this, in order to achieve continuous integration and continuous deployment, there are many tools available in the market. So what are the tools available? What tools we will be using, and how it's related to AWS? And in AWS, what are the services which is providing this CI/CD functionality? We will be talking about all these things, and we'll be doing the things practically as well. The next is overview of Git and Git concepts and Git commands. So let's start with overview of CI/CD. So as I said, like CI/CD stands for continuous integration and continuous deployment. That means as a developer, you keep on creating your code, but deploying is a cumbersome process because deployment goes through many phases. Like first of all, you need to test your code, and your code should be any error free, or it should pass all your test cases. After that, we will build our code. Just like if we have a Java code, and if you build it, building means like making that code in a executable format. Because definitely if you are deploying that code to some server, that text format like Python or Java or C++, that will not run as it is. So that text format code needs to be converted into an executable format. For Java, we convert that into jar files. Jar stands for Java archives. Similarly, if you are designing a web application, we convert the web application code into WAR files, WAR. That means web archives. Similarly, C++, Node.js, Python, every programming language code is converted into an executable format, which can be deployed. Okay, so using CI/CD, we can have more frequent releases. As I told, like release is a cumbersome process, but the CI/CD is making that easy. There is a continuous integration. That means you are concentrating on developing your code or updating your code. As soon as you will commit your code, there will be a continuous integration. Your new code, or I would say your code changes, will be integrated with the existing code. It will be continuous process. You keep on committing your changes into your repository, and it will be integrating accordingly. And similarly, continuous deployment. As soon as you will commit or your code is there in the repository, we can even deploy it continuously. That means we can have more frequent release. If you have a small change, you don't have to worry that, okay, release is a cumbersome process. How would I do that? You don't need to worry about it. Even very small change, you can deploy very easily. So using CI, using continuous integration, we can make incremental code changes frequently and reliably. You don't have to collect, like suppose you are working from last 15 days and you have made code changes in so many files, and then suddenly you will save all the files. That's not required. Even small minor changes you can keep on saving, and those will be keep on integrating automatically behind the scene. Build and test steps triggered by continuous integration ensures that the code changes merged into the repo are reliable. What does that mean? Build and test. You can integrate your test cases in such a way that as and when you are committing any change, it will run the test cases to make sure that whatever changes you are making, is that breaking something or it is everything is fine. That's very important, right? Because suppose current code in your repository is working absolutely fine, there is no issue, there is no error, but you are working on some enhancement and you committed your code changes in the repository. If it will integrate your code changes in the repository and without testing, suppose it will try to deploy on the server, that's not good. So between building your code and deployment, there is a test process which we can configure. So the test steps triggered by CI ensures that code changes merged into the repo are reliable. In case any of the test case is failing, it will not proceed. It will not deploy your code changes into the server. So that's very good thing. You can always define your test cases that if my code is going into production, then all these 10 test cases should pass. Otherwise, please don't deploy. In that case, as a developer, you may have to look into your code again, like why my test cases failed. What is the issue? Is there any error in my code or something like that? You will fix it. And then you will again commit your changes. It will again trigger the continuous integration part, and it will again run the test cases. And if it is passing all the test cases now, that simply means it will go ahead with the deployment. So this way you can have more frequent releases. The code is then delivered quickly and seamlessly as a part of CD process. If all the test cases are passing, then the CD, that is continuous deployment process, will trigger and it will deploy your code quickly. So this is very brief about CI/CD. In upcoming slides, we'll talk more about it. So any question till now?
Neeraj, is it similar to DevOps?
Yes, you are right. You can say that. DevOps is more about like managing your infrastructure as well as your building process and everything. But even as a developer, right, you should be aware because you will be creating the code, you will be deploying it. So this setup, right? Setup maybe DevOps can do. But as a developer, you should be aware about the concept. Like when I commit my code into the repository, what exactly happens? So, but whatever you're saying is correct. It's related to DevOps. So this is just a simple diagram which will give you more idea. So let's start with here. So you plan something like your team is planning that, okay, we will add this feature. After that, you will start coding accordingly. Then you will build. As I said, like when you commit your code, the build process will start. And after build, the test phase is there, which will run your test cases. If all the test cases are passed, that means we are ready for the release. This release is nothing but your code, right? That will be deployed as per your defined. You are deploying on EC2, you are deploying on ECS, you are deploying on Lambda function, or let's forget about AWS. You may be deploying it somewhere else out of AWS as well. After deployment, you will operate. Like you will see what's going on. You will monitor it because whatever features you deployed, are they working fine or is there an issue? Or even suppose they're working fine, you may come up with some more enhancement because as I said, you can have more frequent releases. That means suppose your team is working on 5 different new features. You don't need to deploy those 5 features together, not required. If your 2 features are ready, let's deploy them. Remaining 3 features will deploy later, and it's completely automated process. So once you are monitoring everything is going fine, the next is again plan. You will again plan your next release. So if I talk about my current project, every sprint, our sprint is 2 weeks. Every sprint we are having some production release. It can be small release, it can be big release. So since we have integrated everything, the CI and CD process is in place for us. So we don't have to like do anything manually. We simply decide, okay, this feature and this feature, these 2 features will go into production this time. So we just commit those changes into our Git repository. After that, everything starting from build, we will commit our code. That's a manual process. We will commit our code. Build will process automatically. Test will happen automatically. Then deploy release will be deploying your code. That's happening automatically. Monitoring, as of now, like we validate our changes or we get the feedback from other teams, like this feature is good, please add this more feature, something like that. Then we again plan for the next sprint. We come up with few more user stories and we deploy the next features. So this process is a continuous process and it keeps on going. Any doubts on this one?
No.
Okay, There is one more diagram which can even, like whatever I was explaining, it will give you same idea. You have some code changes. You made some code changes. You will commit this code into the Git repository. There can be some other related code as well, because out of suppose 20 files, you made changes in 2 files only. So you are committing that code into the other related code as well. And then your CI process will start, CI pipeline, continuous integration pipeline. So it will build your code first. It will run your unit test cases. Suppose 5 different team members are working, right? So they may have their own unit test cases. And on top of that, we have integration test, because my individual module is working fine, but that is not sufficient, right? My module should work with other modules as well, and their module should work perfectly with my module. So there should be some integration test as well. If your unit test cases and integration test cases are working fine, that means your CI part is done, continuous integration part is done. Your code changes are successfully integrated into the Git repository. After that, as soon as your CI process is done, CD pipeline will start, continuous deployment. So this is code review. Code review is usually done manually, because suppose as a developer, you create a pull request. What is a pull request? I will explain in the Git section. So you create a pull request. Pull request means you are pulling your code changes into one branch. Then someone will review it. Your team lead or some other architect or someone can review your code, and then you will deploy your code in stage environment. Because before directly deploying into production, that's not a good idea. We will usually do in stage. All these things, right? You are making some code changes, you are building unit test cases. All these things are happening in development environment, so that even if my unit test case fails, even if my integration test fails, that's absolutely fine, because that's my development environment. But if everything is going fine, we will deploy into stage and then we will have a thoroughly testing in stage, because whatever is deployed in stage, exactly the same will go into production. So you can even find some bug or something in stage as well, and if required, you can again make the code changes, again deploy, and everything you can do. And if stage looks good, you can deploy the same into production. So this deploying into the environment is completely part of your continuous deployment pipeline. Now, as I said, like CICD is not a AWS service, it's a concept. In order to achieve this, in order to achieve CICD functionality, what are the tools involved? Let's talk about the tools. You can see that there are a lot of tools for different phases. If I talk about code, there's a Git, which is very famous, very common. Jira can also help you to manage your code, and there is another one is Confluence. These are different like code versioning tools. They can maintain your versions, maintain the history, maintain different teams who can write the code, who can read the code, who can review the code, and all these things. So related to code, these are the services. Then the build process, SBT, which stand for simple build tool, and another one is Maven. These two are the build tools. That means depending upon the type of your code, is it a Python code, Java code, Node.js, these build tools can build your code. They can convert your text code into a runnable format. After that, test. So for test, there is SE, Selenium. Selenium is one of the testing tool, and JUnit is also another testing mechanism, which stands for Java unit test cases. Similarly, for Python, there is a PyTest, which can be used. So it depends upon your programming language, like what type of testing tools you can integrate. If I talk about release, there is a Jenkins. You must have heard the Jenkins name, which is very famous and very common for managing your releases. CodeShip is also there, which does the similar type of things. After that, deploy. You can deploy on AWS like Lambda function, EC2. You can use Docker as well. Docker can also deploy your Docker images. And there is one more is DCOS, that is another deployment service. So you don't need to remember all these things. Just to give you a high level idea that for different phases of your project lifecycle, there are different tools available which provides the CICD functionality. Operate, Chef, Ansible, and Kubernetes. These are the different services using which you can easily operate and monitor. Like if you want to do the graphs on that, how my application is behaving, how many user requests are coming, what is the CPU utilization, what is the storage utilization, is it going beyond 90%, something like that. So all these things you can monitor with Nagios. That is one of the monitoring tool. Splunk is another logging tools. Whatever events, whatever activities are happening on your application, those are being logged into a log server. Splunk is a log server. Datadog is another third-party service which provides the monitoring. It can provide very easy graphs, bar charts, pie chart, and all these things, using which you can quickly monitor your application. Is it behaving perfectly, or is it behaving under performance, over performance? More requests are coming, but your application is not able to handle that, or is there any network issue? All these things you can monitor. Okay, so this is just to give you an idea, like what are the different services available to achieve the CI/CD functionality. So I'm stopping here. In case you are having any doubt till this slide, you can ask me.
No, Neeraj, I'm good.
Okay.